All right, so part 2 notes. We did this first section in the part 1 notes, so we're just going to go on to the second circle. So here, I'm going to draw a coordinate plane, and we did the 30-degree measures last one, so here we're going to look at the 60-degree measure. So now instead of drawing my angle to the x-axis, and again, our whole goal here is to find this point on our circle, the xy coordinate. So if this is a 60-degree measure, that means this inside measure here is 30 degrees. So what I'm going to do is I'm going to build a right triangle to the y-axis. So if this inside of my triangle is 30, then this angle has to be 60. And what I'm going to do is draw another triangle over here to mirror it, such that this is also 30 degrees, and this will be 60 degrees. So now remember, a unit circle has a radius of 1, so that length is 1. This length is 1. And since my angles, this is a 60 degree, 60 degree, 60 degree, that means this is equilateral. So if all of the angles are the same, that means all of these side lengths have to be the same as well. So this side length right here has to equal 1. Now again, we only care about the first triangle we drew. So if the whole thing is 1, that means half of this is just a half. And this is the x distance that we would go over. So now we're going to use the Pythagorean theorem to find our y value. So this would be 1/2 squared plus y squared equals 1 squared. And this should look very similar to the part 1 notes. This is 1/4 plus y squared equals 1. Subtract 1/4 from each side, so y squared equals 3/4. Take the square root. So y equals the square root of 3 over 2. And again, just like the first one, we didn't waste all of this time finding just one coordinate point. We've actually found 4, because remember, these are all going to be the same distance or the same measure, just depending on the quadrant, depends on the sign. So in quadrant 2, the x values are negative, so this would be -1/2, and positive square root of 3 over 2. In quadrant 3, both the x and the y are negative, so this would be -1/2, negative square root of 3 over 2. And in quadrant 4, just the y values are negative, so +1/2, negative square root of 3 over 2. So we're going to go to our unit circle and fill these out. So this would be 1/2, negative square root of 3 over 2, -1/2, square root of 3 over 2, -1/2, negative square root of 3 over 2, and then +1/2, negative square root of 3 over 2. I guess I forgot to put these on when I redid these notes over here. All right, so just 4 more coordinate points. So one more little circle we've got to deal with. So we're going to draw our coordinate plane. And now our last one that we're dealing with is the 45 degree. So what I'm going to do here is, again, I'm going to drop this and make it a right triangle. So if this corner is 45, that means this also has to be 45 degrees. Remember, the hypotenuse here is going to be 1 because it's a unit circle. Well, if you remember any of your properties about 45, 45, 90, or anything generally about 45, 45. So here, if these angles are the same, that means these side lengths have to be the same. So here, we're given that x and y have to be equal to each other. So our normal Pythagorean theorem is x squared plus y squared equals r squared, which is just 1 here, or 1 squared. But since x and y are the same thing, I'm going to replace this y with an x. So really I get x squared plus x squared equals 1. So this is 2x squared equals 1. So x squared equals 1/2. Square root this. So x squared, just x. Square root of 1 is 1. Square root of 2 is square root of 2. Remember, we have to rationalize this, so I'm going to multiply the top and the bottom by the square root of 2. So I get that x equals 1 times the square root of 2 is the square root of 2. And on the denominator, square root of 2 times square root of 2 is just 2. So this is square root of 2 over 2. And since x and y are the same thing, this is also square root of 2 over 2. So now my other 4 points. In quadrant 2, the x values are negative, so this is negative square root of 2 over 2, and then positive square root of 2 over 2. In quadrant 3, both are negative, so negative square root of 2 over 2, negative square root of 2 over 2. And in quadrant 4, x is positive and y is negative, so square root of 2 over 2, and negative square root of 2 over 2. So we're going to go over to our nice unit circle and fill out these remaining points. So square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2, negative square root of 2 over 2, square root of 2 over 2, negative square root of 2 over 2. So your unit circle should be completely filled out. Your goal, if we were still in class doing this, your goal would be to memorize all of this. It's actually easier than it seems to memorize it. I can't really give you a test on it at home to memorize it because it's really easy to just have your paper one right there looking at it. But please note that if you plan on taking pre-calculus or calculus, this is a requirement to memorize both of these. You would have taken one in Algebra 2, a memory test. You will take one in pre-calc and calculus. One of the handful of things that you definitely need to know. All right, so Cooper, why did we do this? What was the whole point of memorizing the unit circle? Great question, class. Let me show you. On one of our previous notes, we talked about SOHCAHTOA and kind of our formula for how to find these when we're constructing triangles on a coordinate plane. And we talked about like x, y's, and r's. Well, here on a unit circle, your radius always equals 1. So this means that sine of theta is normally y over r, is now just y. Cosine of theta is normally x over r, now it's just x. Tangent of theta stays the same, so this is y over x. Cosecant of theta was r over y, but r is now 1. Secant of theta was r over x, but now r is 1. Cotangent of theta is x over y. All right, so now we can use our unit circle to solve some problems. So we're going to do a handful of practice problems. So 1, if I asked, what is the sine of 60 degrees? So what you're going to do is you're going to go to your unit circle, to 60 degrees, and you're going to find the y-coordinate. So when I go to my unit circle, I look at 60 degrees. For some reason, I don't know if I said this earlier, if that was negative, this should be positive. Everything should be positive here. So I look at 60 degrees, I look at the y-coordinate, and that is my answer. So the sine of 60 degrees is square root of 3 over 2. Woo! So now cosine of 5 pi over 4. So here, I'm going to go to 5 pi over 4 on my unit circle. And I'm going to find the x value, and that's going to be my answer. So I go to 5 pi over 4. It's not written the neatest on this one. And I find the x value, and it is negative square root of 2 over 2, and that is my answer. So what the unit circle does is it allows us to, instead of having to have an xy coordinate point and find an angle, it just gives us the ratio of those side lengths for any degree. All right, so let's do tangent of 45 degrees. So I'm going to find 45 degrees. Tangent is y over x. So I look at my unit circle at 45 degrees. I'm going to take my y value and divide it by my x value. So my y value was square root of 2 over 2, divided by my x value, which is square root of 2 over 2. Notice, whenever you have these same denominators here, these will cancel out. And notice that for pretty much all of these fractions, they're all divided by 2, so they should always cancel out. So this will give us square root of 2 over the square root of 2, which is just 1. All right. So let's find a sine of 660 degrees. So now here, 660 degrees is not on my unit circle, but your unit circle will repeat every iteration. It just goes around and around and around. So what I'm going to do is I'm going to subtract, since this is too big, I'm going to subtract 360 degrees to get a coterminal angle that is the same, so that these will end up being within my unit circle. So this is sine of 300 degrees, which is on my unit circle. If it was still too big, I'd just keep subtracting 360. If it was too small, I would add 360. So sine is the y value, so I'm going to go to 300 degrees. And again, my handwriting is not the best on here. 300 degrees. And I look at the y value, and this is negative square root of 3 over 2. Before I keep going, since my handwriting is not the best on these, if you go here, they'll have like a printed out version. You can also just Google unit circle PDF, and it should come up. Just to make sure you wrote everything down. It'd be really hard working off a wrong one. All right, let's try 5. Let's do, actually, I'm going to go up here. So 5, we're going to do cosine of negative 4 pi over 3. So here, this is too small. It's not within our unit circle, so what I'm going to do is I'm going to add 2 pi to find a coterminal angle. So negative 4 pi over 3. 2 pi is the same as 6 pi over 3 because we need common denominators. So really I'm going to be finding cosine of 2 pi over 3. Cosine is the x value, so if I go to 2 pi over 3 and look at the x value, come on. So 2 pi over 3, look at the x value, it is negative 1/2. And yes, you are going to have to show these on your homework. Now some of these, like this one was, you didn't have to show any work, this one didn't have any work. You have to show this work, you have to show this work. I need to see that you know what you're doing. Let's see. Let's do 6. Cosecant of 330 degrees. So cosecant, we wrote on there that it is 1 over y, which is true. You can do it this way. But remember, we also said that this is the reciprocal of sine or the y value. So this is just the reciprocal of y. It makes it a little bit easier to do it as the reciprocal than to make it into a fraction within a fraction. So if I find 330 degrees, so 330 degrees, and I look at the y value, and I try and find the reciprocal. So the reciprocal of negative 1/2, when I flip it, will be negative 2 over 1, or just negative 2. Seven. Let's do secant of 7 pi over 6. So secant, again, we said this is 1 over x, or it's the reciprocal of cosine, or which is the x value. So we're going to find the x value and then flip it instead of using this 1 over x formula. So I go to 7 pi over 6. I find the x value, so that's negative square root of 3 over 2. And then I flip it. So this will give me negative 2 over the square root of 3. I have to rationalize, so I multiply by the square root of 3 over the square root of 3, which will give me negative 2 square roots of 3 over 3. Oh, let's do 1 or 2 more. Actually, video's getting long. Let's just call it a day. Some special ones, if you have 0 over a number, this equals 0. If you have a number divided by 0, this is undefined. There might be 1 or 2 of those on the homework. I don't remember. But again, if you have any issues, make sure you're showing this work here. You're not just going this and boxing your answer. Show your work. Show me how you're getting it. If you have any questions, send me a message or shoot me a remind. And I'll see you guys later.